Right, so this is physics or science paper 1 representation. So in this video, I'm going to revise with you radioactivity. So the question is saying a 400 grams radioactive sample has a half-life of 4 years. So in this case here, we are having two things here. The count rate in count per year and time in years. Okay. So the first question, which is Roman number 1, is saying on a graph paper, plot a graph to show this decay curve after the period of 32 years. So once we come up with the table, we need to end where? On 32 years. So let me display the table. So the first thing here that we need to have count rate in count per year, followed by time in years. Okay, so time here is measured in where? In years. So the first thing, I'm going to start with the original mass, which is 400 grams. 400 grams. Then the time is going to be what? 0. Because the reason why I'm putting 0 here, for something to decay, it needs to start from where? From 0. So which means, in this question here, they are saying, a 400 grams radioactive sample has a half-life of 4 years. So when you find the half of 400 grams, the half-life of that one is going to be what? Or the half-life of this 400 grams is going to be what? 4 years. So in this case here, we all know that when you talk of half, it is more like 1 over 2. So the mass, which is the original mass, which is 400 grams, I'm going to divide it by what? By 2. Or I'm going to multiply it by what? By half. And remember, here they have said after the period of what? 32 years. So we need to end on what? On 32 years. So when I divide 400 grams divided by 2, I'm going to get what? 200 grams. Okay, 200 grams. So in this case here, I'm not going to put grams, but just 200. Then what will be the time? What will be the time? Or what will be the half-life? So in this case here, the half-life is going to be what? It is going to be 4, from 0 up to 4. Then from there now, I'm going to get 200. 200 multiplied by half, I'm going to get what? 100, which is 100 grams. Then on this part here, since here I'm having the half-life of 4 years, which means I'm going to say 4 plus 4. 4 plus 4, then the answer is going to be what? 8. So the half-life of 100 grams is going to be what? 8. Then I'm going to do the same. 100 divided by 2, I'm going to get what? 50, which is 50 grams. Then from there now, since I know that the half-life here, it is 4 years, which means I'm going to add 4 years plus 8. Then the answer is going to be what? 12. Then apart from that one, remember, our ending point here, it is 32. So I'm going to say 50 divided by 2, I'm going to get 25. Then 12 plus 4, I'm going to get what? 16, which is the half-life. Then 25 divided by 2, I'm going to get 12.5. Okay, 12.5. Then the half-life is going to be 16 plus the half-life of 400 grams, which is 4. The answer is going to be what? 20. Then 12.5 multiplied by half or divided by 2. The answer is going to be 6.25. 6.25. Then the half-life here is going to be 20 plus 4. I'm going to get what? 24. Then apart from that one, I'm going to get 6.2 divided by 2, or 6.25. multiplied by half, then the answer is going to be 3.125. 3.125. Then the half-life, I'm going to say 24 plus 4. I'm going to get what? 28. Then lastly, 3.125 multiplied by half or divided by 2. I'm going to get what? 1.5625. Then the half-life is going to be 28 plus 4. I'm going to get what? 32. So remember, 32 is our maximum. Okay, so we are done with the table. So let's try to plot the graph. Okay, so now remember, here we need to plot the graph of count rate in count per year against what? Time in years. So the first thing here, I need to come up with the range. Okay, I need to come up with the range. Since on the count rate, I'm having the maximum mass to be 400 grams, which means I'm going to say 2 centimeters on the graph. It is going to represent what? 50. So count rate is going to be found on the y-axis. So on the y-axis, let me try to write. Okay, it's going to look like this. From 0 up to 400, and for the time in years, since here I'm having the maximum to be 32, so which means as for 2 centimeters on the graph paper, for the time, it is going to represent 4 units. 4 units. And it is going to look like this. Okay. So apart from that one now, let me try to draw the lines and label the axes. So in the y-axis, I'm going to have count rate in count per year. Then as for time, or in the x-axis, I'm going to have time in years. Okay, so let's start with the first one. So the first one, we have 400 grams, comma 0. So 400 grams, comma 0 is going to be on 400 in the y-axis, like this. Okay. Then the next one, we are having 200 grams, comma 4. So 200 grams, comma 4 is going to be here. Then the next one, we are having 100, comma 8. And it is going to be here. Okay, so let me just finish it. So how this graph is going to look is like this, okay? So after that, I need now to join the points by using the free hand. Then, the next one is saying, okay, so let me not forget to put the title. Yeah. So the title is very, very important. So you need to put the title. So the title is the graph of count rate in count per year against time in years. That is our title. Then as for Roman numeral number 2 is saying, what period of time would it take for the sample to reduce to 40 grams? So to determine this one, I'm going to use the graph paper, the same graph paper. Now, in the y-axis, which is the count rate in count per year, 2 centimeters, it is representing 50 units. And there are small 10 boxes in a 2 centimeter. So what I'm going to do, I'm going to say 50 divided by 10, I'm going to get what? 5. Which means a small box is going to represent what? 5. So, what I'm going to do here, I'm going to do like this. So, where 40 is, it is on this point here. So I'm just going to draw a line touching a curve. So once it touches a curve, I need to drop it down to the time. So I'm going to find that it is going to be somewhere like 12 point something there. So let me also do like this, okay? Since in the x-axis, which is time, 2 centimeters, it is representing 4 units. So what I'm going to do like this. 4 divided by 10, I'm going to get what? 0.4. So now, if I'm having 12 here, the next one is going to be 0.4, let me say 12.4. Then the next one is going to be 12.8, followed by 13.2. Then the last one is going to be 13.4. Now since here I'm looking for the time, so I'm going to say the time when the mass is 40 grams is equal to 13.4 years. That's all. Thanks for watching.